I call this the disappearing dots and materializing marks experiment. Okay, it's a rather interesting experiment which tells you about how we see things, or at least one part of how we see things. All you need for this experiment is a sheet of paper, nice clean white paper, a pen, I'm using a black felt pen to draw with, and a ruler, and any ruler will do, and in fact one of the short rulers is fine for this experiment. What I want you to do first is draw a little cross on one side of the sheet of paper, so a little cross. So I'm going to draw a cross there, okay? Now measure about 7 centimetres, which is about there, okay? Doesn't have to be exact. There, make that dot a little bit bigger, okay? Won't be a perfect dot either. And I want you to draw lines coming away from it like this. So almost touching it, but not quite. I'm going to turn my paper around because it's a bit easier for me to do this. Okay. So that's what I want you to do. Okay, simple as that. And of course my line's a bit wiggly. If you want to do it perfectly, you could use the ruler, of course, to draw those lines, and that'd be wonderful if you want to. Great. Let's see what I want you to do now. What I want you to do is hold the sheet of paper in the air. Now, you need to cover one of your eyes. The way I'm going to do this now, and the way I'd like you to do it initially, is cover your left eye with your left hand like this, and hold the sheet of paper in your right hand, okay? Now I'm going to be looking at this while I'm talking, so listen up, this is what I want you to do. Hold the sheet of paper like this. I want you to look at the cross. So that was the X you drew on the left-hand side. Focus on the cross, and notice I'm holding the paper pretty much almost at arm's length, at least 30 centimetres away. Concentrate your eye and your attention on that cross at all times, that X. Do not look away from it, whatever happens, okay? But you'll notice, as I'm noticing now, that I can see the dot and the cross out of the corner of my eye, if you like, across that way. I'm not looking at it directly, but I can see it there. We might call it in our peripheral vision. I can see it, and I want you to pay attention to that. You mustn't look away from the cross, but be aware of what's going on here at the same time. So, very slowly now, keeping your eye glued to that X, your right eye looking at the X, slowly move this sheet towards your face, towards your eye, very slowly. It should take about 20 to 30 seconds. Remember, all the time, although you're staring just at that X, I want you to pay attention just at the corner of your eye to what's happening across to the right. Don't look at it, but just be aware of it. Now stop and go back the other way. Nice and slow. And that's it. Remember, at all times you were concentrating your gaze on that X. You were not looking away from it. What I want you to do is do the same thing and notice what happens with this part of the image out of the corner of your eye. Off you go. So, I wonder what you noticed. I'll tell you what happened for me, and then just compare it for you. When I was moving this towards my eye very slowly, remember, as I asked you, I was paying attention to what was happening here. Even though I wasn't looking directly at it, I was aware of it. I could see it still in the corner of my eye, if you like. I could see the dot and I could see the lines coming away from it. When I got to about there, let's repeat it for myself. When I got it to about, say, there, for me, the dot appeared to vanish. I can't actually see that dot anymore now. All I can see is the cross. And yet when I move it closer, the dot appears again. I can see it now. Even though I'm not looking directly at it, I can see it out of the corner of my eye. I can see it even clearer now, of course. When I move it back again, at about the same position, that dot has vanished for me. I can't see it at all. All I can see is the cross. I can see the arms of the cross. And it looks to me like a complete cross, if I'm honest to you. Then I shall move it further out, and the dot's appeared again. I can see it now. Oh, it's appeared again. Okay. Now some people report slightly different things to me. That's what I saw. I know a lot of people I've done this experiment with see what I see. But I do know that some people tell me that occasionally to them the dot does disappear, but they see, for example, an L shape or two L shapes, which is interesting. So they see L shapes appearing. Some say they see a line, a continuous line, either one direction or the other direction with a gap between. But most people I've done this with tell me they see a complete cross when the dot disappears. But the fact is the dot has disappeared and something else has replaced it, which is quite amazing. I wonder what's going on there. So how come that dot disappears? It's right in front of your eyes and it disappears. What's going on? Well, let me explain a couple of things first you need to remember. First of all, the back of your eye, my eye in here, the back layer is covered in millions of little light sensors, okay? And there are about 130 million, we think, about that. Now, all of those little sensors send a little signal eventually to your brain, but they can't all go in one big mass to your brain. What happens is they all collect together and go through a big nerve called the optic nerve. And it collects together at the back of your eye. And actually, if you're looking at me now, the optic nerve on my right eye is, if you could see it, it's towards the back of my eye. Imagine again, there's the back of my eye, it's there, next to my nose. So if I point, I was sort of pointing at it now, it's there, right in my eye at the back, and it goes out. And on my left eye, the other is pointing that way. So both of the optic nerves go out of the back of my eye in that direction, the direction I'm pointing. Now where that nerve leaves your eye, the very spot it leaves it, we call it the optic disc. And at that precise point, no light sensors are there. They can't be there. The optic disc is where there's no sensors at all. So when you look at an image, whatever it is, all that image is going into your eye and landing on the back of your eyeball, and a little image appears on the back of your eyeball. Your lens helps project it there. And all your sensors in the back of your eye pick that up. But where that optic disc is, wherever that picture lands there, whatever's in the picture, you can't see it. Your eye can't detect it, and so your brain doesn't see it. One other name for the optic disc is called the blind spot. And some of you may have heard of this, the blind spot. And that's why it's called that, because you're blind at that tiny point in your eye. Now, of course, you don't normally notice it in everyday looking around, because you are looking around all the time and you're moving constantly, so you wouldn't notice it. And the other thing is your left eye covers a slightly different image. And what you can't see with your optic disc here, your left eye can usually see it, and your brain combines the images anyway, so you don't notice it. When you do an experiment like this, and hold this in the air, now the image, of course, is just going in one eye. I've blocked this eye totally. The image is going in one eye only. And when I get to about here, where that dot disappears for me, the image of where that dot is must be landing directly on my optic nerve. Imagine it going through my eyeball in a straight line and hitting that little disc I've described on the back of my eye, on the back layer. That image is landing there. But there's no light sensors there, so I can't see it. But here's the interesting thing. Why don't I just get like a fuzzy nothingness there? How come I see something? For me, I saw the whole cross. What's going on? There was no cross there. Look, you can definitely see it's not a cross. It's a broken cross with a dot. So how do I see a cross? This is where it gets interesting. Because scientists think what happens is, where the optic disc is, your brain thinks, okay, I can't see there anyway, but you guess what could be there. And your brain thinks, well, I'm going to look what's immediately around it. And what it notices, it thinks, well, I can see what's around it. And from that information, I can fill in probably what's going to be where the optic disc should be seeing. In my case, I looked at this, and my brain obviously thinks that when it saw that fuzzy blob of nothingness, if you like, where it was landing on the optic disc, my brain probably thought, oh, well, that must be a cross. I'm going to fill it in and make it look like a cross. Now, of course, some people clearly don't think that. Their brain probably thought it could be an L shape or maybe two L shapes close to each other. Or some people's brains probably thought, oh no, it must be a straight line, I'll make it look like a straight line. So that's why we do get variables in there in what people actually see. Depends how your brain chooses to decide what it must be in the middle. But isn't that weird? Your brain fills it in for you. Amazing stuff. So, what other things could you try? Interesting, lots of little things on this one's great. How about changing the dimensions, the measurements we've used? So for example, draw your cross wherever you choose to, but don't make it 7 centimetres to the little dot when you first draw it, make it more or less. So try that first. So in other words, move this whole part further or nearer to it. What about if you use the other eye? Of course, that's an obvious thing to do. Try the other eye, see if you get a similar thing with that or not. What about if we change the length of these lines that I've drawn here? Make them longer or shorter? What about if we change the angle? Because I've got a line going in that direction and that direction here, what we might call vertically and horizontally for the angle I'm looking at it. How about drawing diagonals instead? There and there. How about actually drawing those lines on even now? Drawing a line there, there, there and there. So we have 8 lines radiating out in all directions. What about using different colour pens? So I've used black here. Do you think that makes a difference? How about trying different colours to see if that makes a difference in what you see? What about different colour paper? We're using white paper here. What about darker colour papers or lighter colour papers or brighter perhaps, say bright yellow? That'd be an interesting one because I don't think you're going to get lighter than white, but something that looks brighter perhaps to you, so a bright yellow. Actually, you get fluorescent papers, don't you? These fluorescent, really shiny ones. How about those? Actually, thinking of shiny, what about using tin foil, cooking foil? You can get pens that write on that, so do it on cooking foil. I wonder what that would do. That'd be an interesting one. See if you can think of a few more things.